Okay, so experimental probability. This is actually what does occur in an experiment when you're actually performing trials. Sometimes you might also see it, and you'll probably see it in grade 9 also, called relative frequency. So it means like the frequency that an event is occurring. Okay, so we can calculate it using a similar formula to theoretical probability, but this time we're looking for that number of specific outcomes. Like if you're performing trials, what was the outcome that you were looking for specifically, divided by the total number of outcomes, so however many trials you actually ran. So I'm going to use a pretty basic example, but it should be okay for getting you guys to understand the experimental probability. So I'm going to be rolling just a regular dice 12 times, and we're just going to see what we get for the outcomes. Now, theoretically, I know that each number on this 6-sided die has a 1 in 6 chance of being rolled, right? If I was looking at number 1, it has a 1 in 6 chance. If I had looked at number 2, it has a 1 in 6 chance. Basically, so that they all equal 6 out of the 6, they each have an equal chance of getting rolled. If I was to do this trial 12 times and instead look at a fraction that's over 12, I'm basically just doubling it, right? Times 2, so they all have a 2 out of 12 chance. So by the end of my 12 trials, what I should see is each number getting rolled twice, theoretically. But we know experimental probability is often very different, right? You're going to see that there are trends that happened. It could be completely random. There might be a number that's rolled 6 times. So this is why we always kind of compare theoretical and experimental probability. So let's go ahead and start the experiment. So trial 1 will be a 6. Okay, a 4, a 3, oh, that was a 3, a 2, a 1, 5, a 2, a 3, that was a 6, a 1, and a 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so there's my 12 different trials. So now I can actually look and see what did I end up getting. So if I was looking for a specific outcome of how many times did I roll the number 1? 1 was rolled, 1, 2. Okay, 2 out of the 12. So right now, my theoretical and my experimental probabilities for rolling a 1 are correct. I did in fact roll that 2 out of the 12 times. Let's look at number 2. If I rolled 2, 1, 2, 2 out of the 12 trials, that one has their theoretical and the experimental probability correct as well. Let's look at 3. 1, 2, 3. So 3 out of 12. I rolled this one a little more than I thought I should. So if we look at what it should have been when it was 1/6, I think it's 1 over 6 was equal to 13%, no, 16%, 0.16 or 16%. So if I calculate this, what actually happened with my 3 divided by 12, was it was rolled the 25%, right? 0.25 or 25%. So it occurred about 9% more than it should have. Okay, that one's kind of an interesting one. Let's look at 4. 4 was rolled once, 1 out of 12. Okay, so if we consider what this one was, 1 divided by 12 is that 0.083 or 8.3%. So it occurred about half as less as it should have. All right, that's one that the theoretical and the experimental ones didn't match up. If we look at 5, that only occurred once out of the 12 trials, so same thing, 8.3%. That one did not match the theoretical probability, and then 6, 1, 2, that one did, 2 out of 12. Okay, so if I was to actually take a look at this experiment, I would say that the theoretical and the experimental probability matched up pretty close. It wasn't like I had one number that was rolled 50% of the time. So I would actually look at this as a pretty successful experiment that matched the theoretical probability when we think of the experimental probability, right? So if you think back to that formula, the experimental probability is the number of specific outcomes over the number of total outcomes. Okay, so specifically, if we looked at the number 1, it occurred 2 out of the 12 times, 2, 2 out of the 12 times, 3, 3 out of the 12 times, not terrible, 4, 1 out of the 12 times, also not terrible, 5, 1 out of the 12 times, and then 6, 2 out of the 12 times. Now, if we think of our total outcomes of just being over 12, that's not a lot of trials. And if you can imagine, if we did this 1,200 times, we'd probably have much bigger variances, right? The more trials that you add, the more you might see your experimental probability matching or not necessarily matching with your theoretical probability. So that's why it's important to perform enough trials that you get a really clear idea. Okay, hopefully this helped.